Right, I think that's going. I need to get the link so I can tweet it, which would be under there, I'd imagine. Yes. Right, sorry about that. I was just setting up the live stream stuff. Welcome if you've arrived. It says there's one watching. Well, I'm not sure if that's me watching myself or otherwise. Okay, so the NSIDC have released 168 years of Arctic sea ice data, which they've regenerated from some logs from sailing vessels and whaling boats. So I've just downloaded it. It came in as a NetCDF file, which is one of these jobs. I have processed it using a C# NetCDF library that Microsoft have released. This is the code that I've used to extract each individual measure from the latitude and longitude grids, and then I had to work out which area each of those were referring to. So we had a little bit of spherical area mathematics going on here, and then I just put it out into a simple CSV kind of format, which you can see some of the output just here. So I've just recently just set the data format correctly. I'm just going to extract that into a text file. That will only take a moment. So what I'm going to do with this is graph some of it just to see what we can get out of it, and then try to make some sort of animation or some such. So this is the file here. Let's have a look at the output. So it's pretty much as expected. This is saying that in January 1850 there was 12 million square kilometers of sea ice in the Arctic. As you can see, it reduces down to about 5 or 6 come September, which is a September minimum. And yeah, so we've got 168 years of that, all the way down to 2013. Now there's some overlap with data from satellites, which is this data here. You can see we've got a lot more of that, and it's daily records, whilst the regenerated data is monthly, and it just so happens to be the 15th of each month, which is presumably it's because it's halfway through the month. Right, so first thing we want to do is possibly put that into a spreadsheet. Unfortunately, I just realised I don't have a Excel license, so I won't be able to do it with Microsoft stuff. I guess what we could do is just stick it into a Google Drive one and see what kind of mess we can get out of that. Let's make a new sheet on there. Right. Let's import. I've not actually done this before. Drag a file, that'll do. I might have to change its name to a CSV for it to recognize it. So let's do that. Excellent. Right, does it recognize that as a date though? Is the next question. So how do we do format date? Date 1850. Aha, fantastic. Right. So let's see if we can graph that. Chart, I guess. Right. Interesting. Okay, so what we've got here is, I don't know how that's going to come out on the screen grab. It's got a lot of detail, but you can see that there's seasonal. Let's see if we can squash that down a bit, make it a bit easier to see. There we go. So it looks like there's definitely a seasonal cycle there. Fairly consistent. Let's get rid of that. And a little bit of a decline towards the end there, but that only goes to 2013. 2016 had a really sharp drop. So that's cool. So the data looks fairly consistent. I haven't messed up my output, which I'm quite pleased about. So let's continue on. Right. So what I'll be using is a language called processing. And it's a stupid name for a language as far as I'm concerned, but what it is, it's a library that it's a Java library that can be used, and it's quite straightforward and simple. It comes with a editor which is very simple to use, so let's just copy that into this one that I've just already set up. So this is just some of the data I've got. That was some old data that I was messing around with, and that's the original NetCDF file. So what I'll do is I'll create a new text file, which is going to be a processing thing, which I think is PDE off the top of my head. Yes, I'd like to rename that. Yes, so now we've got a processing source file here. Key thing is that you've got to make sure that it's the same file name as the folder you're in. It's just one of the requirements of processing. So we'll open that up and see where we go. It's a bit slow, but we'll get there. Okay, so empty text file. What processing requires is just two functions. One is setup, and the other one is draw. So what we can do is just make sure that everything is working quite nicely, simply by going hello. Save that. If we run that, we should end up with hello down in the bottom here. Why don't we have hello in the console? Probably because this print line. I'll try that. Still nothing. That's weird. What have we done wrong? Is it lowercase setup, I think. Ah, there we go. So you can see it's blue highlighted, so it's beginner's mistake. There we go. Run that. There we go. Hello. So we're all up and running. Right. So generally in the setup, that's where you can load in the data. It's a bit of a faff to do that, so I can just grab some code that I've already written in previous examples. Do I have some actually? Oh yes, ice anomaly countryside. I'll do it. And let's open that one up. Okay, let's go review. Right, we don't need to worry so much about this. This is previous data, so use up to there. Use loading. No, that's the wrong function, Kev. Wrong function. We want to load the function, not get the load the data, not get the data. What's this one? No. Load data. That's what we want. So that is Arctic 1850, I believe I called it. Okay, so it's going to read through, don't have to worry about that. Get rid of you. Split the line. We want the date time, which is 0, and that splits on space. Why would I want to be splitting on space for? Oh yeah. You want? Ah, okay, so it had time on it, so we don't want that. Don't worry about that. It's pretty straightforward. And let's create a data dictionary, or a hash table as the old guys call it. Right, and the date is, what's date? My God. I thought string date. Ah, okay. So date time is that? No, should I just change that to date? That's fine. Okay, I guess a 0 reads the line, puts into the dictionary. Fantastic. That means I should be able to print out, let's say 1850 101. Okay, 50, and actually what we want to do is data dot get 1850, and hopefully that will spit out the line from 1850, if that's right. No. Ooh, boy, we've done wrong. Right. That's because I haven't loaded the data yet. Haha! Let's try that. Still no. Alright. What have I done wrong? Oh, it's 1850-15. There we go. January 15th, 1850. There we go. So it's saying on the 15th of January 1850, we've got 12.4 million square kilometers. So we've got. So the setup is executed when you first run. So it gets executed once. So you can set up things like to load data and set up your screen size and colors and fonts and all that sort of stuff. So what this is doing is obviously it says printing hello, and then we want to load the data. To load the data, we want to load strings from the Arctic CSV file that I've got. Now what that does is it creates an array of strings, one per line, and then you loop through that through. So for each line in lines, we want to split the line on commas. So we've got just the one comma in this example. Date value is the first one, zero based, and then the line is the rest. So you can see that so that will load into a what they call a dictionary, which is date is the key, line is the value that we're storing. So this is going to put the value, the key 18500115, and it's associating it with the line that it is the complete line, which is the string 185001, 12.4 million square miles, kilometers. So then after we've loaded that into the dictionary, so this is done all rows, so we can get it from any date, any year. So let's say 1974. Now there's a good year. Run that, we should get a different value. So we get 11.73 million square kilometers. Fantastic. Right. So now that we've got the data loaded in a way that we can get access to it, we want to be able to loop through that data in a logical manner. Now conveniently we've got this data in one value per month, so we don't have to worry about wonky month lengths like February having 28 days and some other months have got 31 and 30, so we can just simply loop through 1 to 12 on the month, and from 1850 all the way to 2013, so we can extract all that out. So that's fairly straightforward to do. So let's do a for loop. So we want to have an integer, let's call it year, month even. Do we want to know month? We'll go year first. Yeah, starting with at 1850, at whilst the year is less than or equal to 2013, increment year by 1. And then for each year we want to loop through the month. So let's go int month equals 1. Month is less than or equal to 12. And month is plus. Now what am I doing? Oh, my font size, sorry. Thank you, Jeffer. Font size, can I do that? Let's see. Edit. Tools. Must be a way. Bear with, I'm just going to do some Googling. Processing the font size. Okay, what do we got? So, oh, editor.font montspace in the preference.text. Where do they have that? Preferences, user box. They have preferences on here. Reference. Environment. That sounds plausible. Ooh, okay. Tools, maybe do file preferences. Here we go. Editor font size. Ah, right, let's go 18. How about that? That's much better. Okay, let's pop that back over there so I can see what's going on. Right. Is that better? Can you see that? Alright. Where was I? Month. Right. Okay, so that's going to loop through, so we can print out year plus month plus -15. No worries there, Jaffa. Is it Jaffa? How do you pronounce that, mate? Right. Okay. So that hopefully should spit out dates down the screen as I run it. There we go. So we can see that it goes. Oh, that was really quick. Okay. I don't know if this font down here is going to be big enough for you to see. Don't know, you can increase the font size on that, but I'll bear with anyway. At the so we can see that we need to zero pad the month to be able to get the correct values. So, oh gosh, how would you do that? How do we zero pad in Java? Hey, my string.format probably. Let's do some quick googling. I've been coding for 20 years and I still have to Google simple stuff like how to format a string. Java string format. It's probably sprintf or something like that, no doubt. Format examples. Let's, so you can see what I'm doing. String.format. That's what I thought. Alright, so he's going %s. Okay, that's cool. We can do that. String.format. So what you do is wrap that in string.format, give it the format which is %012, I think, 02D, so that's D meaning decimal, 02 means two zero pads, so two digit, and zero pad the spaces, and % just means this is a format. So so let's give that a go. Got it right first time, fantastic. Okay, so that means that we can loop through all the dates in the range that we've got. I'll just check what the last value is on 2013. That would be interesting. We don't want to overdo that, so oops, unable to open Arctic 15. Oh, I've closed it. Bear with. What have I done? I didn't close it, I actually changed the name of it, didn't I? There we go. Right, so that goes up to conveniently 12th. So that should be. What am I doing wrong? Go over there. I want my IDE. There it is. So that should be 2013, 12, 15. So that'll be the last date, which is brilliant. Right, put that back over there. Okay. Right, so now that we've got that, this is going to be the main loops in our draw function. At the moment, I've got that in the setup just so that we can get the output correct. So let's tidy that up a little bit. So let's move that into the draw function. Now what draw does is it runs once per frame of the animation, so we've got to be fairly optimal in our coding in here, because you don't want to loop through 168 years of data every single time. So clearly we don't want to go from 1850 to 2013 every single frame. We probably will be in the last few frames, but we don't want to do that right from the very start. So what processing has is a variable which is called frame count. So we could, let's say, just to start off with, have it increase the year once every frame. So let's do that. So our start year will be 1850. Actually, no, our start year is going to be 1849. And then we're going to, whoops, that's wrong, year equals 1849 plus frame, no, this is the end year, my mistake. So we've got the start year and we've got the end year, so we want to start at year and end with end year. How about that? That makes much more sense. And then we can't spell. Right, notice that it didn't go orange. And it's because I need to get a capital C there. Oh, actually it's not orange, it's more of a magenta. So you can see that so every time draw is executed, end year will increment, will start off at 1849. First frame count is 1, so it'll be 1849 plus 1, which will be 1850, which actually doesn't make sense. It will be 1850 to less than or equal to 1850, so that loop won't actually run. So let's actually change that back to 1850, and then it will be 1850 to 1851, which would make much more sense. So let's change that, take that, and so that's our end year. So every time draw is executed, it'll add an extra year to the frame, so we can see something appear slowly on the screen, one would hope. Now the other fun part is that this will also render 1 full year of data per frame, which is probably what we would want, because we've got 168 years of it, so it's going to take a very long time to actually render them all. So I guess we'll start off with this anyway, and so if I run this now, and then we'll just stick an exit there. So oops, try that again. What is wrong with my fingers? Yeah. Alright, what this is going to do, let's get rid of that. Don't need you anymore, and get rid of you as well. Right, so what this will do is it will, in the draw, it will hopefully print the year 1850 and each month in 1850, possibly also 1851. So let's do that. So let's run that, and it should exit as well. There we go. So we've got 1850 01, 1850 12, then 1851 01 to 1851 12. So that's exactly what we want. Right, so actually what we do possibly want to do is knock that back to 1849, because the first frame I actually only want to display the first year. So let's do that. So hopefully they'll only display 1 year. Fantastic, we've only got 12 values there. Alright, so now what we want to do is that we've got the data loaded, so instead of just printing out the year, we're going to store that value. It's going to be the date. So that's a string. It's string date equals that, script of that, and that means that we've got this value sitting in the date variable. Now what we can do is output the data that is associated with that date that we have just created. So let's do that. Data.get the data approach with the date, and hopefully that will spit out not only the year, not only the date, but also the square kilometers of the sea ice area. In fact it does, and I did print, not print line, so it's gone and stuck it all on one line. So let's do that again so we can actually read it. Here we go. So we've got the date and we've got the sea ice area. So now we're cooking. So we've got some data and we've got the date. So what are we going to do with this then? Options are many. We could we'll start off with a simple graph going from left to right, and see what kind of mess we make of this. We're going to get it wrong from the start. We're going to get the scales going to be all wrong. It's going to be either too fast or too slow, but we won't know until we actually do it. So first thing we actually want to do is set the size of the screen, and I have completely forgotten what the actual function is for that. So let's go on to processing.org, the reference, and this is the page that I spend most of my life on. So we want to get the screen size, screen XYZ, nope, maybe it's window size. I'll just search for size. Maybe it's just size. In fact, I think it is just size. There we go. So let's start off with 1000 by 1000. That always seems to be a good way to start. And we want to have a nice black background, so let's change the background color to black. And let's make the stroke a nice bright yellow, which would be, off the top of my head, full red, so that'll be 255, full green, and no blue. And we want to be able to actually see it because I'm streaming, and it is stroke weight. I'll make that a 3. Alright, so this is so basically I'm just setting up so I've set the background color to black, set the stroke to if you've got just one value in there, it just assumes that it's going to be something like that. So that's the full value. If you've got one value, it just copies the number to the red, green and blue channels as well. So stroke here we've got full red, full green and no blue, so hopefully I think that's yellow. And the stroke weight makes that makes all the lines 3 pixels wide, so hopefully you should be able to see that. So if I run that, you'll see a big black square. Oops, okay. Oh, I thought it would be a big black square. Oh, of course. The reason why is because it showed it very quickly and closed it because I've got that exit there. We'll leave that for the moment anyway, but I see that it actually did work. Right, it's guys probably talking to me and I don't actually see what you're doing, so let's go back to that. Hi. Is there 15,000 miles away with live coding? I hope you're enjoying it there, William. Oh, hello, we've got seeing my private Google stuff. What's going on here? Right. Okay. Right, where were we? We are just about to actually display something. So we've got the data. So let's, we don't need to print that out anymore because we know that works, and we can stop this exit. So first thing actually we want to do, I just remembered, is that instead of having the background there, because that only executes once, each frame we actually want to make our life easier by clearing the previous frame. If you don't actually clear the previous frame, you end up drawing over top of it each time. So what this line does is it just clears the frame to black, and then you just start all over again. So what we'll do is do a line. So we got line, and the first value is going to be the frame count. Now, because we've got increasing the frame count. So what we'll do is we'll have a integer that is our x value. It starts off as 0. Put that outside the loop. So we'll have the line starting from x as 0. We'll increment that as we go. Our y value is going to be the data. So first of all we need to get our y value. So let's that's going to be a float value. So it's floating point. So let's make it float. Y equals data. This is going to be wrong. I already know this is going to be wrong before I actually type it. So let's continue on. We can see where I go. So get based on date. So unfortunately it's going to be red squigglies because the return value of that is a string and it doesn't match float. So actually what we want to do is change that to that, and let's just say we'll just call it data. So then we want to split data because we've got so the output of that is comma. So we need to split that on there. So I think I can just go dot split and make that comma. Is it going to let me do that? Nope. It's going to be a. I'm doing this wrong. Split string. Oh no, I'm doing it wrong. Forgetting my own language, forgetting too many languages in my brain, and we'll go split. That's more like it. And then we go comma on the character called comma. Still getting it wrong. Oh god, I've forgotten it. Bear with. This is the sort of stuff that I need to Google every single time I do it. So we go Java string split. How do you do it? You do it by find split string regular expression. I want to do a regular expression. Split a string. That is not very helpful information. Java string split. This is a bit embarrassing. The very simplest method. It is lowercase s. No, it's not. It is. Yeah, I was right the first time. So let's. So that goes dot split, and I want to split on a comma. Right. The reason why it was red and squiggly is because that's now outputting an array. There we go. So data is an array, but actually all I care about is the second value, so obviously index 1, and that's now a string again. So there we go. So the actual data, so that what that complicated looking line is, it's taken this value, split it on string, and I've taken the second value here, and so the value that's going into data is this string. It's not a number yet. That's key. So then to be able to make it an actual float of, we'll call it something proper like ice area equals, you use the float method, or float function, give it a string, which is the data, and that will convert the string data into the float and give it and place the value into the ice area. So there we've got the ice area. Now if I just plot that directly, it's going to be 12 pixels high and it's going to look ridiculous. So let's create our y value, take our ice area, and let's multiply it by 10. Is 120. Now make it 100. And I normally go .0 like that just to make sure that it stays as a float. It will do, but I just find that a little easier to read. Okay, so So, alright, back to the line. So we're going to start off with x equals 0. We've got to increment it as it goes. So what that basically means is that the next time we use x is going to be 1, and then it's going to be 2, 3, 4. So it'll go across the screen quite nicely. Y is going to be this value of ice area times 100. Now, the thing you need to remember is that the y value, the 0 of y is at the top of the screen. So we need to flip that over by taking our screen height, which is conveniently in a variable called screen height, and subtract y from that. And it's not screen height, is it? No. Is it screen h? No. Or was it just height? Height! Height it was. Alright, height minus y. And then we want to have a line going to somewhere, so that's going to be x. Now x here is going to be so that's going to be off here as 0. Because we've got this plus plus here, x over here is going to be 1. How cool is that? Unfortunately, we're not going to have anything interesting regarding y, so let's just whack that in like that anyway, and we'll see what kind of output we get, but it's going to be a bit weird. So, right, I think that's all we need to do for the moment, so let's run that and see what kind of mess we get. I'm guessing that something's going to appear on the screen, but I have no idea what it's going to look like, so let's go with that. Alright, who was expecting lines? I was expecting lines. So what's happened here is that we're getting squares because these are 2 by 2, well actually no, they're 2 by 3 yellow pixels. The reason for that is that that's a very short line, and that's because I'm using the same y value each time we're drawing. So what we need to do is draw from a previous value of y to the next value of y. So let's do that then. So let's close that. Oh hello, what's going on here? It's not responding. Oh gosh, close the program. I'll just close the program. Thank you. Right, I cannot run the sketch. That's fine. Right. Okay, so let's so we need to remember our previous value for y. So I normally do is create a variable called last y and set it to 0, and let's make it nice and easy to read and do the same thing for that. Now, so we also need to know that we need to store the last value of y. So the first time we go through, we want to get the value of y. Actually no, we'll just leave that in the moment, so we'll do that, and then we'll go last y height, and that should be the next one, and then what we need to make sure we do is to record last y. So we need to do last y equals y, so that's going to remember the previous value of y, which is ice area times 100. So hopefully that should give us some lines to look at. So let's do that. There we go. Right, so now we've got some lines, but don't they look rubbish? So what's going on here? Let's have a think. Right, let's stop that. Right. So let's read through what we've made. Let's just tidy this up a bit. It's a bit messy. Okay, so we're getting the data. I've got the data. I think the data's fine. Ice area is cool. The y value is the ice area times 100, so I think it's probably a bit too big. So let's knock that down to 50 just to make it a bit more sensible. Alright, so the height minus last y and height minus y. Am I doing that right? So height in this case is going to be 1000 minus a sensible value of y. Height minus y. Alright. Let's do that anyway, see if it's it was just simply the scale. Ah, that's what it was, just the scale was too big and it was going way off the top of the screen. Anyway, still, the scale is still too big, and we can't really see any detail on that. We're just getting lots of zebra lines. So let's spread them out a bit. And what we can do that with is multiplying the x value by a certain amount. So let's go, oh, I don't know, 10 times x, and do the same thing over here, otherwise it will go particularly messy. Let's try that. There we go. So, and this should be very fast. You're not even going to see much of it. I'll just go whoop. There we go. There we go. So a bit of detail there now. Okay. What can we do with this? I think we could probably actually slow it down a bit. Now we can. Oh, why does it keep on doing this? Close the program. Cancel that. Right. Stop. Right. I think I just need to hit the stop button as opposed to just shutting that window down. It's a bit weird. Right. Okay, so how can we slow it down? Because it's going too fast, and what you do with that is muck about with frame count. So to slow it down, what you do is you divide frame count by a certain amount. So if you want to go 10 times slower, you just divide frame count by 10. Now that's going to give strange values into end year, but will it? If end year was a floating point value, then yes, you'll get strange values. But because it's an integer, it'll go, it'll round that value. So it'll, so for the first few frames, well, every 10 frames, the value won't change, and then it will increment by 1, and then the next 10 frames it will remain the same. So it'll go 18. Well, it'll be 1850, 1850, 1850, 1850 for 10, and then it'll go 1851 for 10, 1851 for 10, 1851 for 10. So that should slow it down 10 times. Hopefully that will give us a bit of a slower drawing. There we go. So it goes like that. You can see it was quite quite a lot of lines. There was 12 lines were drawn per frame for that. I don't really like that. I want it to be able to draw each month as we go along. How am I going to do that then? So really what our problem is that we don't really want to divide it by 10. What we want to do is increment the month per frame, and then when month gets to 13, increment the year. So if we've got end year value here, so let's create a new variable called end month as well. Clearly end month will always be 12, well, it'll max out at 12. So let's define end month up here, and let's say we need to start off with 1, and then each frame we want to increment it by 1. Trouble is, every time draw gets executed, end month will start off as 1 here. So what we need to do is that end month needs to remember its previous one from the previous frame. So what you do is you stick, you take it outside of draw, and you just basically move it. Oh, I can't do it in here. Let's take that out there and place the definition of it outside draw, and that way end month will remember its previous value. Probably going to need to do the same thing with end year. In fact, I think I will. Frame count now is going to get a bit screwy. It will not work out there. So let's just start end year off at 1849. Let's clear that definition. So now what we've got to do is increment end month by 1 every frame, and then when it hits 13, we increment the year by 1 and then set end month back to 1 again. So, right, so let's say end month starts off as 1. Just to make our life easier, let's make end month start off at 0. And that means we can just blindly go end month plus plus. And then if we find that end month is greater than 12, then we can sort out these brackets first. Then we can set end month back to 1, and then increment end year by 1, just like that, and hopefully that should work. In fact, now that we've got end year up there, if we, I know why it's crashing. It's because end year is going beyond 2013, I think. I'm not stopping it. Yes, because end year used to be the frame count, so once the frame count goes up to 2013, it busts, and we get a null value in the data, and then everything goes to pot. So what we'll do here is we'll go if end year is greater than 2013, yes, then we'll simply exit, and it'll stop before it crashes. Right, I think that works. So what we're doing is we're putting end month and end year outside of draw, so that means that they can remember its previous value. We can then increment end month by 1 per frame. If that goes over 12, then we reset end month back to 1 again, and then increment the year. And if the end year goes over 2013, then we just stop the animation. So let's see what that looks like. Okay, I was not expecting that. What on earth is going on there? Interesting. At least it's not crashing now. What have we done there? Alright, let's have a think. So we're incrementing the month. Oh, it's something to do with the X value, isn't it? There you go. You don't want that. Right, we're setting it to 0. Okay, let's have a think about this then. So as we're alright, so we need an X start. Okay, that was 10 times X. Right, let's simplify that. Let's get rid of the 10 times malarkey. Right, what am I doing wrong? That's going to look the same, just tighter. Yeah. Interesting effect, but not particularly useful for what we want. What is it doing? Okay, so when we draw, we set X to 0. Starts off at month 1, goes to month to end month, end year, year to the starts at 1850. So I can't see what the problem is, to be honest. What am I doing wrong? Alright. I don't like that in there anyway, so let's go with X there. We can change that to X plus 1. Or whatever we like. I should probably go with X. And then where am I going to increment X correctly? So each time we draw from 1850 to 1851, we want to draw X. So it's going to increment X, go to the next one, repeat, increment X. That's what I feel is going to happen, but that's no different to what I had before. I don't know what I'm doing. Yeah, it's no different to what I had before. Of course, it starts at 0 each time here, which is probably what draws that. That's the month. I actually can't figure this out. This is a bit strange. In the first month will be January 1850, and the x will be 0 as you would expect. Increment it by 1. The next line it's going to draw is 1 to the right. Let's area float. X, Y, blah, 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 blah. It should draw the same line and then add an extra one. Draw the same line and then add an extra one. Why is it so nasty like that? I really don't know what's going on. 10 times that. What am I doing wrong here then? Ooh, that's interesting. Draws it. It just goes crazy. The X value is just going weird. Do I want to increment? Yes, I do. I want to increment X. Let's just make that bigger just so I can see what's going on. What's going on up there? So that's X plus 1 plus 1 plus 1. Wait a minute, that's, I know what's going on there. That's because I'm doing that. Let's try that. Alright. It draws a line, but then it does this wiggly stuff up the top there. This is weird. It's very strange. Right. X is 0. Last y is 0. Loop through the years, loop through the months. Get the data for that value. End month increases by 1. If end month is greater than 12, end month is 1. Set the end year as that. If the end year is greater than 2013, exit. Gets the ice area, scales it. So the y value is correct, it's the x value is all weird. Each frame is different. Why? Set the frame rate a bit slower. Let's make it 10 frames a second. What is going on there? Alright, let's make that even slower. Right, so that's right. Okay, I think it's there's definitely something to do with me multiplying x by 10. That's just bonkers. Kind of pretty though, but okay. So this stays correct. What on earth am I doing wrong there? Something weird about me doing that. Alright. Let's not do that then. Let's say x is that. X plus 1. Goodness me. Right. Show you that. 1850 goes to 1. So it starts off correct. Increments x by that. What am I doing wrong? Setting it to 0 to start with, that's correct, that's all correct. It just goes a bit, it just keeps on scaling it out per, is it year? Let's stop that, let's wipe that. Those 20s back in, they were quite useful. So it does 12, and it does 12, so every 12 frames it's skipping, what is it doing? Let's even slow that down. 1 a second, slow as a wet week, but I'll at least be able to see it. Really slow. Come on. What's going on? There it goes. So it goes to 12, then it resets back to there. Alright, I don't think it's my X. I think it's me working out my end month and stuff. So draws it, increments end month by 1. If it's greater than 12, sets end month to 1, increments end year by 1, And just going through things. So what happens there then? So first value that comes through is 1849. That's wrong for a start because we're not doing that frame count thing. So now it's going to be 1850 it's going to start off with. And then it will do 12 frames of that, 1850. No. Is it because I set that to 1849? That starts off a bit quicker. It goes back to 12 again. Let's print out the values of end year and end month. What are we getting? 1850. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1. 1851. 2, 3, 4, 5. Okay. So that's cycling through as one would expect. But why does it do that? Oh, I know why. Ah, you muppet. It should only stop the end month on the last year that we're animating, not every year. So when it does end month of 1853, for example, it stops in January for each time it does a loop. That's what's going on. So we should only change end month when it's the last year that we're looking at. Oh god, right, how am I going to work that thing? Oh, muppet. Okay, so this is wrong. Actually no, that's wrong. End month is fine, it's just that we only use end month when it's the last year. Right. Okay, so what we do there, I think, is let's create another, not var, wrong language. I am in Java, which means I want to use int the month equals 12. Okay. So let's do that. So that becomes the month, right? So normal state of affairs, you want to loop through all 12 months. If year is equal to the end year, if year is equal to end year, then equal to the end year, then set the month equal to end month. That, I think, is it. So we go, so first one's going to be 1850. So if the year is 1850, which will be the very first one, set the month to end month, which would be the first month, which is 1, because we've incremented it there. So it will do January, and then it will do February. Right, so then 1850 becomes the end year of it will become 1851, and the month will be 12. The year does not equal the end year, so it'll be 12, and then we'll do all 12 things, and then yeah, I think we got it right. How about that? Oh yeah, we're still going slow. Yeah, forgot about that. Well, we'll wait until it's 18. It's September, October, November, December, January, February. Ah, we did it. Right, let's speed that back up again. Stick it back to normal. Go. Hey! Did it. Right, well, that's the most boring looking animation now, isn't it? Hey, thanks, William. Eureka, exactly. Right, okay. Ah, you gotta love coding. It just drives you mad sometimes. Yeah. Right, let's yeah. I think what we'll do, we'll start off at 20 and then we'll just keep reducing that down. Perhaps, I don't know. Or we'll just scroll across the screen. Let's go scrolling. I like to scroll. Let's go scrolling. So, oh, that's going to be a bit tricky though, because we've got year and month. I think what I do, this nested for loops, these two loops are going to be very annoying to work with. Now what we could do is have the time variable to be just month, and we just keep on incrementing month beyond 12 and 13. We just work with that, and then we work out the year based on what value the month is, and then we've only got one for loop to worry about, and we don't have to keep on resetting this value. And that means that we can then do some funky cool stuff with scrolling or whatever we want to do to do it. So let's get rid of this loop and its associated thing. All right. Let's tidy that up. Okay, now that we've done that, we want to go with right, so most of this now is going to be a bit rubbish, so we don't want to have, we don't need end year anymore. End month will be what we're working with. So we keep on incrementing in month. If it goes over 12, we don't care. We just wanted to keep that going. We don't worry about the end year just yet. And we can get rid of you as well. That was only debugging purposes. Int x is 0. Yes, we do want that. Last y we definitely want. The month equals 12. You'll keep the month variable. I think we'll keep that. But we're not going to use it there anymore. We're going to use that in there. And then we don't want to worry about the year, so let's tidy that up. Now month is going to keep on increasing, so we'll change that back to end of month, and that's just going to keep on increasing until we hit 168 years worth of months. Fine. Right, so what is 168 years worth of months? Get my calculator out. 168 times 12 is 2016. Serious? Oh, what? That doesn't make. Why is it almost this year? 1850. That seems far too coincidental. Have I done that wrong? 168 years, 1850. Right. Well, let's do this properly. So 2018 now, crikey. Minus 1850 is 168. Oh no, it's not 168 because we're going to 2013. Yeah, 2013 minus 1850 is actually only 163 years. So I've been telling you lies. I haven't got 168 years worth of data. I've got 163 years worth of data times 12, which equals 1956. Does that make sense? Because plus 12, I think, I would imagine on that. let's work it out a different way. Right, so right, so now that we have the month, now we need to work out what the year is. So the year is going to be a modulus. Month. No, it's going to be divided by 12, isn't it? It's just be simply month divided by 12. And I didn't put an equals in there. Month divided by 12. And then we want to, so month will start off as 1. Divided by 12 is going to be 1. It's going to be divided by 12. Because in integer it will stay 1 for 12 values, and then it will go to 2 for 12 values, and then 3 for 12 values. But we want to have our starting year as 1849. Yep, and then the actual month is going to be month modulus, which is conveniently the percent figure, 12. Right. And we're going to change that to the month. And I've probably got that wrong. So let's print that out. So it's going to be year plus the month. And watch me make a mess of that. 1849, 1, crash, boom, null pointer exception, hooray! Because it's 1849. So this actually should be 1850. How about that? Because 1 divided by 12 is 0 when it's an integer. Holy shit. I think I might have mostly got that right, except it doesn't actually increment the year at all. What's going on there? So it goes, oh, hang on. 1851, 1851, 1852, 1851, 1852. Oh, it goes 1. It goes 1, 2, 1, 2, 3. 1, 2, 3, 4. Ah, that's going right. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. That's correct. 1, 2, 3, 4, 9, 10. And then it goes 11 and dies there. Why does it die there? Because it's 0. We don't want a 0 month. That doesn't make any sense. Why did the month go to 0? Because it was that. So we started off at okay, I know what to do. Set that to 0. But that's weird, Kev. Why would you do that? But then you increment that by 1. And that means that the number, this will go in a range of 0 to 11. You add 1 to the 0 to 11, you end up with 1 to 12. Right, give that a bash. Bloody hell, that works a treat. Cool. Right, stop that. Okay. How long have we been doing this? Go, 1 hour 18. Oh gee. I'll have to figure out when to stop. Okay. I think I'll get it to the point where I can scroll nicely across the screen and we can see the whole data set. It's not going to be the most interesting of animations, but it'll do. Okay. So now that we can loop with only one loop, what we can do now is modify the starting month and the end month, so we don't have to draw all of the lines all of the time, but only enough of the lines to fit in the screen. So I like the scaling of multiplying it by 20. That gives it a nice value. So 20 divided by 1000, which is 50. So we only want to draw 50 lines per frame, which means it's 50 months. So how are we going to do that? So we get to do the first 50 frames. It's going to be as per normal, and then once you get to the 50 frames you want to increment that value by 1. Alright, so we need a start month now. Now, do we need to remember the value of start month? We'll start off like this. So let's go start month. Month equals 0. There we go. Then we want if start month, if frame count is greater than 50, OUNT, then we increment start month by 1. Month. Right, what's that going to achieve? That'll be fine. I know what this is going to look like. We'll draw our little snake, and then the snake tail will disappear off to the right of the screen. So let's do that and see if I'm right. Doodly-doo. Oh, okay, that wasn't what I was expecting at all. What have I done wrong there? Start month. That was unexpected. Hang on about. Did that actually crash, or did it actually draw? Why did it do that? Oh! Aha! We do need to have that outside the value there, so we can remember what the start month was. Right. And then it will do what I'm expecting it to do. Well, there we go. That was actually what I wanted it to do, not what I was expecting it to do at all. Why is that working? Whee! Look at that go. It's nice when I get it to do what I wanted it to do, but it's not nice that I didn't expect it to do it. And it crashes because I didn't put an end point in. Let's stop that. Oh, I don't know, it's not going to stop, is it? Oh, it did stop. Right. Actually, I can do it nice and simple. If year is greater than 2013, exit. Do that. It makes the math a little bit easier to work out. Right. Why didn't that do what I was expecting it to do? So the start month is that, end month is that. Oh, it's because X is set to 0. Ah, that's why. Ah, that's good. That's fine. That makes sense. Right. That just means our last. You noticed that when it was working, that Y starts off at 0 each time down there. So that's because that's there, which means I should actually just remove that, put that out the bottom, at the top. It's almost like, you know, if all else fails, stick it outside the draw variable and you're good. Right. Oh, what? Okay, I get it. Oh god. So that's remembering the last frame that the last line that it drew, and it's drawing it as the first value. Tell you what we'll do is undo that, because that was actually correct the first time. So it's that we don't want to draw the first line. So let's get a boolean. First line equals true. And then we don't want to draw the first line, so if, actually we'll change that to draw line. Makes it a little bit easier to read, and do false. If draw a line, and draw the line. So So that starts off as false. Last wire is that, and then all we need to do is go draw a line equals true. Which means that we do end up with a gap there, but worse things have happened. Right. And then I think what we could do is slow that down. Don't want to change the frame rate though. Let's what we'll do is we create our own customized frame count value. The frame count equals the frame count, but we'll divide it by 2, and then we'll use that to there. And that's not going to help because x is still going to increment by 1. No, that's a load of bollocks. Let's undo that. Now we'll just change the frame rate. Change that because I think it's at 60 frames a second. So let's knock it down to 30. Not the frame rate. The frame rate. And let's go with that. There we go. That's a little bit easier on the eyes. And that, I think I will leave it there. Thank you very much for watching. I think I might continue with this on tomorrow night if you think that's a good idea. Actually, we'll see if that gets to the end without crashing. I think my logic does actually work. What I'd like to do is get this into a more interesting thing, maybe a spiral or a barrel. I don't know if a bit of barrel, but a spiral I think would actually work quite well with this. And then once we get closer to, I think it's 1979, we get some satellite data, we can put daily values in, and then push that through to the latest values, and it will be a very long animation, so I'd have to make it very fast, otherwise people go to sleep watching it. There we go. Oh, it does crash. Boo! Anyway, thank you all for watching. Oh, hang on, let's stop that. And we'll leave it at that. How do you stop this thing?